Okay, first thing we want to talk about is product rule. So product rule applies to functions that are products of other functions. So I have one function multiplied by another function multiplied by another function, so on and so forth, right? So here I have some arbitrary function f of x, and f of x equals a sub x times b sub x times c sub x, where a, b, and c are some other functions of x. The derivative of f, which is going to be d dx with respect to x, that means I change x. I'm trying to figure out how much f is changing because the derivative gives me the rate of change of f with respect to x is going to equal the derivative of a times b times c, where b and c are the original functions, and I've only taken the derivative of a, plus the derivative of b times a times c, where a and c are the same, and then the derivative of c, where a and b are the same. Okay, so here I'm changing a, I'm keeping b and c constant. Here I'm changing b, I'm keeping a and c constant. Here I'm changing c, and I'm keeping a and b constant. If I add all of these together, then this gives me the rate of change of f. So this term tells me how much f of x changes as I change a with x. This term tells me how much does f of x change as I change b with x. And this tells me how much does f of x change as I change c. Well, if I add these together, say a is changing with x, b is changing with x, c is changing with x, I add those together, I get the total rate of change of f of x, right? I'm actually going to rewrite this over here on the left just to make it a little neater. So this d dx is the derivative operator. I can just write this as df dx. That's the rate of change of f divided by the rate of change of x. So that means if I increase x by 1 unit, this is going to give me how much I increase f. Okay, let's do an example. So I've got f of x equals ln of x times e sub x, or e sub x times ln of x. Doesn't really matter because of commutative property. So what I'm going to do is, first I've got e sub x, I've got ln of x. So now f of x is the product of these two functions. So df dx is going to equal the derivative d dx of e to the x times the original ln of x plus the derivative of ln of x d dx ln x times the original e to x. Okay. Well, what's the derivative of e to the x? The derivative of e to the x is just itself. So I'll do e to the x, and then I multiply that by ln x. So this is this, and this is this over here. And then here's my original ln x. Likewise here, I'll underline these as well. So d ln x is going to equal 1 over x, right? And then multiplied by my e to the x over here. And this is my final equation. So final answer, df x equals e to the x ln x plus e to the x divided by x, right? And I can use distributive property. I can just take e to the x out of here, and I can just say this is ln x plus 1 over x. And that's product rule. And it's a very important rule in calculus that helps you solve a variety of different derivatives.